All right, so the factored form here, we got the first type of factoring you would ever learn is what's called GCF factoring, or greatest common factor. And the greatest common factor can be, it can be either a letter referring to a variable, or it can be a number, or it can be both. So in this problem, the x is what you factor out of each. So you divide each of these by x. Can you tell me what would go in parentheses here when you divide each of those by x?
So that'd be, it'd still have an x to the 3 power, wouldn't it? Or
So
would
that what
it-
they cancel.
Okay.
So it's like, and the rule is, I mean, and so there's a couple other things. So the rule is if it's x to the n over x to the m, this equals x to the n minus m. So when you have a 3 and a 1, you subtract them. 3 minus 1 gives you x squared.
Okay. That makes
So
sense.
how about the next one here? What would 4x squared divided by x be?
4x.
Yes. And then x divided by x is just 1. It cancels. And the minus comes from that.
See that we already answered it.
Yes. So this is the final answer. I guess that looks like it's D.
Yeah.
Okay. So what I want you to do here for number 6 is I want you to try to do the same thing for me, but this time there is both a letter and a number, but let's just focus on the letter here for the first part. I want you to divide each of these by n. I'm just going to step away for 30 seconds. I need to grab some water. I will be right back though.
Yeah, just the one.
All right, I'm going to write what goes in parentheses here, and you can check your work. Okay.
Okay, that's what I got.
Okay, and I mentioned in the previous problem that you can also get a number. In this case, the number has to go in each of these, and it's 6. So I'm gonna put the 6 here, and again, you just divide everything by 6. So this time you're just dealing with the numbers. So like 6 divided by 6 is 1, 24 divided by 6 is 4, 18 divided by 6 is 3.
Okay. So you still put the, oh, because you're factoring it out, so the 6 in goes on the outside.
Yes.
Okay. That's an answer. I feel like it has to go further, but I guess that's where you would stop, isn't it?
So one of the challenges with teaching factoring is it's not always clear when to stop. And that's what you're asking yourself, right? You're saying like, well, when do I stop, Matthew? And the answer is, well, when it's done being factored, which isn't helpful. But what you have to do is you go through all the factoring options and you say, I think I've checked them all. And this is, this is my best guess. It really is a good life skill. Like you would try things over and over again until you're like, I think I did it. I think I did everything I can do here. But we're going to do kind of one more here. We're going to do 9. It's kind of a backwards question. Actually, now that I see it, I guess I understand what the instructor is doing. So we're going to go through. Yeah. If it was 8x plus 2y, do you see that you could factor a 2 out of both?
Yeah, I do.
Okay. And let's say it was 8x plus 12y. Do you see that you could factor a 4 out of both?
Yes.
And actually, I'm going to move, and I guess I'll slide this down a little bit. Let's say it was 8x plus 16y. You could factor an 8 out of both.
Mhm.
So in all three of these, do you see that there's an extra, like there's a factor step?
Yes.
Okay. And so on here. But if we put the value of 7 in, which is the
Mhm.
correct answer, by the way, there is no, this is what's called prime, or it's unfactorable from here.
Okay.
So what they're saying here in this question, they're saying like, choose the number where you don't have to do any more work.
Okay.
And if you get that number, then you can stop. And that's how we know the answer is 7 on that.
Okay, that seems so backwards because I'm like, we were solving it with the other
Yes,
numbers.
yes. And yeah, and your instructor has chosen to do that over and over again. What do you mind telling me which high school, university you're taking this out of?
This high school is Wakayakam. That's
Okay.
in Washington.
Okay.
A lot of people know about it. It's really up there. It's Wakayakam High School, and then I go to LCC, which is Lower Columbia College, and that's in Washington also.
Got it. Got it. Yeah, so I asked because I've seen there's another university high school integration thing that they use a lot of the similar types of questions, but it's a different one. So, all right, I guess I'm just going to go back to number 1.
Okay.
I don't have a lot of like guidance for like, don't have a way to guide you through this anymore, because the next type of factoring that often you see is what's called difference of squares.
Yeah.
And this is a difference of squares, not the 3, but the x squared minus 4. So what difference of squares says is like if you have a squared minus b squared, it has to be a minus, it has to be a difference. There is no sum of squares. It becomes a minus b, a plus b. Okay, so well, how does that help you? Well, in your problem, it's really x squared minus 2 squared. You see that 4 is really 2 squared.
Yeah. Okay.
So your a is x and your b is 2. B is never negative. B is always the thing that you're squaring.
Okay.
So then you simply write it as x minus 2, x plus 2.
Okay.
Difference of squares always has subtraction, and it always has 2 terms.
Mm-hmm.
All right, so I think the answer here is that it's equivalent, but it is not completely factored.
Right, because we tore it apart.
Yes, you can continue to, yeah, factoring really is a breaking down of it. Let me look and see if there's any other difference of squares problems. Yeah, so actually 8
Okay.
is of that type. So again, I know that, and you know that now because it's 2 terms, 1 and 2. So our options are like, you can't look at it like this. You have to look at it like it's x squared minus 12, x squared minus 36, x squared minus 49, and x squared minus 81.
Right.
And maybe you see right away that this is really x squared minus 6 squared. This is x squared minus 7 squared. And this is x squared minus 9 squared.
Right.
So these are all difference of squares.
Mm-hmm.
And the order doesn't matter. If you want to write plus instead of minus, that's fine. I probably always do it this way, but I couldn't say for sure. So they're saying, well, which one makes this completely factored? Basically, like you see that the last 3 are difference of squares. So
Yeah.
therefore it must be the first one because
Okay.
Okay, so then the next type of problem that you might see when you're talking about factoring. So I guess I'm kind of resetting here each time. So when you think of factoring, I was talking to a student and like you can think of this as like, there's like, let's say you want to get somewhere. There's, you could walk, you can ride a bicycle, you can take a bus, you can drive. There's options. You can get a friend to take you. I mean, factoring is kind of like that. There's different types and some work better than others in some situations. So GCF, difference of squares. And then the third one that you often see is what's called a perfect square trinomial. I should actually write that out. Perfect square trinomial. Okay, and that's what we're going to see in question 3. Kind of telling you the answer, but I'll show you why it's the answer, which is what you've got to be on the lookout for. Identification is really important here. So perfect square trinomial, there's some steps here. You have to take the square root of the first term. This is the first term, and that's x. Then you take the square root of the last term, which is 6. Okay, and then you merge them, and then you double, and then you ask yourself, is that the same as the middle term?
Okay.
Is it the same? And it
Yeah,
is.
yeah.
It is. Okay, so this is a perfect square trinomial. And I mean, that is the answer. Now there's 2 forms of a perfect square trinomial that I should cover here. So let me give you the other one, but it's really similar to this. X squared minus 12x plus 36. So again, same process. You take the square root of the first term, you take the square root of the last term, you merge them together, then you double, and you get 12x. And you say, well, hey, Matthew, that isn't the same. And you're right, it's not the same. There's 2 forms, though, of perfect square trinomial. This is the other form, though. So it's a squared plus 2ab plus b squared, or it's a squared minus 2ab plus b squared. So in your last problem, it becomes a plus b squared, and then this one is a minus b squared. So it's either got to be plus plus or minus plus. The minus turns into this minus, this plus turns into this plus.
Okay. It's never minus, it's always minus plus.
Yeah, so here are the ones that are, these are the no's. I mean, we already said a few of them. There is no like a squared plus b squared. This is sum of squares. This is nothing.
Okay.
And then just to answer your question, if it's a squared minus 2ab minus b squared, this is also a no. This is no. Or if it's a squared plus 2ab minus b squared, and these are based on what I'm seeing, this is what you'll see on the exam. These are the wrong form. And you can see it's just a small difference, plus plus or minus plus. Those are perfect square trinomials. So what your instructor will do, he'll give you something like, I mean, this is probably how the exam question will appear. You'll get something well, you'll get something like this. It'll be like x squared minus 6x, I'm sorry, minus 12x plus a, and it'll say for what value of a makes this a perfect square trinomial. And your answers will be like, the correct answer will be down here, which is 36, but some wrong answers will be like minus 36, maybe 144, maybe, I don't know, 6. But that's how your instructor will do it. Or they'll ask you for this middle term. But that's kind of an aside there. So, okay, let's go to question. Yeah, let's go to question 7.
Okay.
So this is the fourth or fifth type of factoring. So there's factoring when you have something in this form, ax squared plus bx plus c, and one type is when a equals 1, and another type is when a does not equal 1. This is the type where a does not equal 1. So the step is to take 6 and 10, basically that first number and that last number, you multiply them together.
Mm-hmm.
And then you find all the possibilities that work here to multiply these together. And I'm not gonna switch the signs. I'm just gonna run through them this way. So minus 3 and 20, minus 4 and 15, minus 5 and 12, and minus 6 and 10. Okay. And we ask ourselves, do any of these add up to 7? And the answer is right there.
Oh, yeah.
Okay. So here's why that's important. So what you do is instead of writing 7x, you say, oh, 7x is really 12x minus 5x. And you're like, why would I do that? Because it gets worse before it gets better. It's just the way it is here. Doesn't make any sense, but that's what it is. And then you look at these first two. This is called factor by grouping now. So type A equals 1 turns into this, what's called factor by grouping.
Mm-hmm.
And you look at the first two and you say, what's common between them? And you say, oh, there's a 6 and an x. So you factor that out of both, 6x plus, or x plus 2. Okay, and then what you do here, this is where it's getting more difficult, is you immediately write this over here, this x plus 2 over here, and you figure out what goes in this position so that when you multiply it in, you get back to the previous line. And the answer is minus 5.
Right.
Okay, and then this is the hard part. This is still, I used to call this a double factoring because you end up doing this twice. Do you see that this is the same in both?
Yes, I do.
So you write that over here, and then you bring down the other stuff, which is 6x minus 5.
Okay. You leave it like that?
Yes, this is done. Okay, but it doesn't answer the question. We got to go back. What it says, one of the factors is, and you have to compare these two factors to that answer key.
Okay. Boy, do they make it really hard.
They sure do. There's a lot of disguising of questions here, and it's really pretty tough. I'm sorry, this is just the way it is here.
I know.
All right, so factor by grouping, which is what we just did after we separated it, what you're looking for is 4 terms. Okay, but, and this one has 4 terms, but do you see how you can actually combine a couple to start?
Yeah.
So this is really 9x squared plus 5x plus 10.
Yeah.
Problem is, I think the instructor meant to make one of these cubed. I really think the instructor meant that. Because the other factor by grouping thing that you're looking for is usually sometimes there's a cubic or power of 3.
Yeah.
Because this one right here does not factor.
Mm-hmm.
And let me show you how it does factor if it's the other one. So if I just slightly rewrite it, okay, you can factor out of the first two a 3x squared. And then you can also put an x plus 2 over here, because you always take whatever's here and you move it over here, plus 5. And this actually works really nicely. 3x squared plus 5 times x plus 2. So it looks like there's an error in this. The correct answer is factor by grouping, but it's that because there's this has to be a cube in it.
Yeah. Okay.
Right. How about, let's see, I'll make sure we know where we're at. We've done one, two, we have not done, so we could do two. We've done three, we've done four, we've done five, we've done six, we've done seven, we've done eight, and we've done nine. Okay, so I intentionally left 2 and 10 to the end because they're the ones that require you to look at each one by one here and decide if they're right or not. So let me write them down one by one here, and we'll just go through them. Okay. So let me actually start by we did GCF, we did difference of squares, we did what's called perfect square trinomial, we did a equals 1 kind of, and then we did a not equal to 1. We kind of also did grouping, factor by grouping. Do any of those appear to be correct here? Any of these?
No.
So this is a GCF. What is the GCF?
Oh, right. It's G.
Yeah, and then this is actually difference of squares, which we haven't covered yet. It's a higher order, and there's a this list keeps going. There's more than this, but that's so obviously this is not the right answer. Okay,
Right.
so let's look at the next one here. 4g cubed plus 18g squared plus 20g. Okay, what say you? Does this look like any of the ones that we've done already?
Yes, it does.
Okay. Can you either tell me the name or tell me what you would do to this right here?
We would we do the GFC.
GCF, yeah. And it's actually both a letter and a number this time.
Yeah, because you would do 4 also.
Actually, it's 2 because 18 doesn't go,
Yeah.
which I was about to do, and that gives you 2g squared plus 9g plus 10. And this is actually factorable also. So we know it's not this one. So we just continue. It's okay, well, let's look at the next one here. Now, I don't know if you've been noticing this, but whenever it says which of the following, and maybe I've already said this to you, but whenever it says which of the following or which, you really need to start from the bottom up, because
Yeah, you did say that.
okay, so if you're doing this on an exam, please do it from the bottom up. That way it'll save you some time. So this one here, it's another GCF. The GCF is 6g squared. So you're dividing each of these by 6g squared. Oops, it's just 4 minus g squared, which is also a difference of squares. So obviously, since we did that, the last one is
Right.
must be the answer.
But it also makes sense because you can't really divide 2, 5, and 4 with any number.
But remember, it could be a different method. So let me so what you're supposed to do here with this one is, because it's an a not equal to 1, meaning this first one is not 1, you're actually supposed to take 2 and 4 and multiply them, and then write all the factors of 2 and 4, and do any of these add up to 5? And the answer is no. So that is why. And it's, it's by exception. It's like, nope, that we know the answer is in this group of 4. So it's no, 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 yes. But that's, if you just were to look at this one and it was free response, you'd have to indicate why it's not.
Right.
So similarly, we have to look at the last grouping here for number 10. Kind of go through them all here. 10. So 4 times 4x to the 4th minus 1. All right, so this one is actually difference of squares. And you're like, how is it difference of squares? So you got to figure out what squared minus what squared gets you back to this line right here. And the 4 on the outside, I mean, it just comes down. It's not part of it.
Okay.
So like what squared gets you to 1? Well, that's easy. It's 1. Okay. But for 4, maybe you know that that's 2. I'm sure you know that, but like, what do you square to get back to x to the 4th? Well, it's x squared.
Okay.
And this is your a, and this is your b. So this becomes, and it's remember, it's a minus b, a plus b. You ignore the squares. Once you figure out what it is that a is, you just exclude those. So it's 2x minus 2x squared minus 1, 2x squared plus 1.
Okay. And since we were able to work, it's not factored completely off.
Yeah, this one, yeah, it's not this answer. Yeah, it's so let's look at the next one. I mean, these are really good questions, but if you don't know this stuff, you're just not going to be able to have any way to do it. So just look at this on the inside here. Anything that you notice here, please, take 30 seconds here if you need, but please take a look on that.
There's also an X and a Y.
Forget about that. Forget the X.
Yeah.
Just blot it out. It's gone. Just look at the stuff on the inside there. Do you see how everything has a Y in it?
Yes.
So you can factor a Y out.
Yes.
So this is obviously not, this one can be factored. So it's not completely factored, which is weird. It's really weird to say that.
Okay.
Okay, so then the next one here is 3x 9x squared plus 1. This right here is called sum of squares, which is not, there is no such thing. There's no formula for that. Okay, so this is your correct answer.
So they always put the correct answer on the bottom?
No, not always, but a lot of the times. Now, if the software that develops if the software in the, so okay, like if you and I were setting out to write a test taking strategy on standardized tests, and we were saying whenever there's which of the following questions, and we said, hey, you really want to start from the bottom up, okay? And we taught students that. Well, that's because we are expecting the answer to be down here, which is like normally the case. So it's like on average, you would expect to save time doing it that way, but you can't just make the decision, because if software comes in and they just scramble it or randomize it, you don't know.
Right.
And then you're sitting there saying, well, so try not to outthink the way the test was designed. But in these homeworks, for sure, like it's very clear that these are not scrambled. They're just, they're really, hey, let's do them.
My dad got
like
told once that you always select C, you cannot figure out the answer. And he took a test to be a loan officer, and he did that, and he's like, it doesn't work. I'm like, no, I'm not going to do that.
No. Another one I teach is that A is the most common wrong answer that you think is right. Because what A is generally an intermediate answer. And because you get a number and you see, oh, that's right there, well, it must be correct.
Yeah.
And the answer is no, it's not. And then it ends up being that it's letter, one of the other ones, because you're supposed to use that answer to do this. So like all of these things put together should help you excel when you're taking a standardized test, but it's hard to remember.
Yeah.
And that's why usually students have to take standardized tests a couple of times, mostly to get familiar with the style and then to kind of realize some of these things that help them in that time, when that time comes.
Yeah. Standard testing is something that's really hard to get used to.
Yes.
I broke down crying my first time I did standardized testing.
They're tough. They're tough. They're designed to be difficult, and yeah.
Yeah.
So
they're great at crying about writing a paragraph. It doesn't sound right, but that was what the big deal was.
Oh. Are you reading anything good lately? Any personal reading or still just school stuff?
I was reading personal, and then the quarter started and I've been way too busy, but I was reading about pretty much like Vikings and stuff. And it was kind of cool to like, I don't know, like I feel like it's a time that it doesn't get talked about a lot because I guess it's kind of like super gory and stuff. But it was interesting to like hear about it, like Eric Leaf, discovering like the United States before even Columbus did, even though that Columbus got the credit kind of. Everybody's like, oh, like we just found it, but we're not really sure who found it.
Right. Yeah.
But anyways, it's interesting to read about.
Cool.
And I know we still have time.
Well, it kind of just with the cancellation or things yesterday. I mean, if you're okay, it would help me a lot to actually stop here for the rest of the day.
Totally fine.
All right. I will send you the notes and the screen recording here shortly, and I'll see you next time.
Thank you.
Have a great day. Bye now.